Okay, so now we're going to try another method for solving. Okay, so far to solve quadratic equations, we've used factoring, and we've also used SAMDEB from vertex form. So one method that always works is the quadratic formula, but we have to go from standard form equal to 0. Okay, so that's ax squared plus bx plus c equals 0. The quadratic formula can be derived from solving from vertex form, so using SAMDEB, using letters rather than numbers. And in your textbook, you can look at one of the actual investigations of how it is solved to vertex form, and then using SAMDEB to rearrange it to isolate for x. But the key thing to remember is that when you want to get the x values, okay, so this is saying the x value that makes the equation equal 0. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so there's a little video with using Pop Goes the Weasel, and we can sing that in class as well, but the key thing is that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's look at this example 1, where you're given standard form equation, 2x squared plus 4x minus 5 equals 0. So from this, we need to determine what our a, our b, and our c values are. So we can see here that a is 2, b was positive 4, and c was negative 5. So wherever a, b, and c appear in the quadratic formula, we're going to plug in those values. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times the a value. We can then simplify those values. So 4 squared gives us 16. Negative 4 times 2 times negative 5 gives us plus 40. So 16 plus 40 is 56. So we have negative 4 plus or minus the square root of 56, all divided by the 2 times 2, which is 4. We then can take the square root of 56, and we can go to 2, 3, or 4 decimals. The key thing is that it's not 1 decimal, so do not round it to 1 decimal place. So what this is saying is because we had plus or minus the square root, we actually have 2 different roots. We have x can equal negative 4 plus the square root value, all divided by 4, or x can equal negative 4 minus the square root value, all divided by 4. And then you can simplify the numerator and divide by the denominator. And so we get 2 different values. One root was x equals 0.871, and the other value occurs at x equals negative 2.871. And these are just estimates because we took the square root of 56, which is in a perfect square. All right, so we're now going to look at example 2. I've set up the sheet, so I want you to try and solve using quadratic formula. Determine your a, your b, and your c value, and watch your signs. Okay, so pause the video, complete this question, and then press play when you're ready to check your work. Alright, so determining our a, b, and c value, you should have gotten an a value of 1, a b value of negative 15, and a c value of 56. So plugging into the quadratic formula, x equals the opposite of b, so a positive 15, plus or minus the square root of negative 15 squared, which will give you 225, minus 4 times 1 times 56, which will give you minus 224, all divided by 2 times 1. So when we simplify, we're saying the square root of 225 minus 224, which is the square root of 1, which is 1. So 15 plus or minus 1, all divided by 2. So our 2 roots will be 15 plus 1, all divided by 2, so 16 over 2, which is 8. Or our other root would be 15 minus 1, all divided by 2. I'm sorry, there's a typo there. Divided by 2. So 14 over 2 is 7. So our two roots are 7 and 8. So the key thing that you need to remember is that your quadratic must equal 0 and be in standard form before you can use the quadratic formula to solve. So let's try example 3. Okay, so notice we're dealing with a vertex form equation. So you could just do SAM-DEB to isolate for x, or you could expand this into standard form. So expanding x minus 2 squared, you're going to get x squared minus 4x plus 4 minus the 3. So collect like terms and then determine your a, your b, and your c values, and then plug it into quadratic formula and solve. So pause the video, work this out, and then press play when you're ready to. Okay, so having simplified and collected your like terms, you should get an a value of 1, a b value of negative 4, and then combining the 4 and the negative 3, you get a c value of 1. Plug in your values into the quadratic formula and simplify. So you have a positive 4 plus or minus the square root of 16 minus 4, all divided by 2. So 4 plus or minus the square root of 12, all divided by 2. Now if we continue on and take the square root of 12, it's not a perfect square, so we get a decimal, so we write it to 3 places. And then you can do your two roots, one of the addition and one of the subtraction, and simplify to the decimal places. So we can see that we had two real number roots. So that means that we have two x-intercepts. Okay, so two roots or two x-intercepts. So they're real numbers, we can see them. Exact form is when you leave it as a square root rather than changing it into a decimal, unless it's a perfect square. So you take any of your perfect squares out. So you can see that if we had the square root of 12, and we say, well, what is 12? Well, 12 is the numbers 4 times 3, where 4 is a perfect square. So we can take the square root of 4 and take the 2 times the root 3. You can then simplify this more, or you can leave it in this form, and this is exact form. So we have no decimals. This is exact form. So this is what university level students and AP level students are required to leave it in, and your textbook will also leave it in exact form. But you can just check your answers by going to decimals, by actually doing the square root of 3 as a decimal times 2 and checking it with your answer. So you can see one final way that you can write your answer. If we simplify it one more time, and I'll just bring that up over here. Dividing our values, you're going to get 2 from 4 divided by 2. And let's see if we can do it this way. 2 plus or minus, oops, other side, 2 plus or minus, sorry, oh, now it's not doing it. Okay, so 2 plus the square root of 3. Let's see if it will give me the square root of 3, or, oops, sorry, or our other root would be x equals 2 minus the square root of 3. And that's from having simplified our 4 divided by 2 and our 2 divided by 2 times root 3. Okay, so that would be the exact form that you could also write it in for bonus marks. Okay, so I'm not concerned about this. I will accept the decimal values, but also if you want exact form bonus marks, take out your perfect squares and simplify it as much as possible. All right, let's try another example. I want you to try example 4. Okay, hopefully it will. There we go. Okay, so solve 0 equals x squared minus 6x plus 9. Pause the video, complete it, and press play when you're ready to check your work. Okay, so when you've simplified this one, we're saying the opposite of negative 6, so positive 6, plus or minus the square root of negative 6 squared, which gives you 36, minus 4 times 1 times 9, which also gives you 36. So we're saying 36 minus 36 underneath our square root symbol, which is the square root of 0. Well, the square root of 0 is just simply 0. So you can see that when we do the addition and subtraction, 6 plus 0 divided by 2 and 6 minus 0 divided by 2, we can see that we got 3 as our only root. Okay, so what that's saying is we only have one real root, we only have one x-intercept, and that should end up being your vertex. Okay, if you were to simplify this and factor this, you would see this is a perfect square at x minus 3 in brackets squared, which gives you a vertex of 3, 0. Okay, so it matches up. The last example I want you to practice for right now, example 5, is vertex form. Okay, so go ahead, simplify this, and then we'll come back once you've completed it to check your work. Alright, so having expanded x plus 2 in brackets squared and collecting like terms, in standard form we get 0 equals x squared plus 4x plus 7. So your a value is 1, your b value is 4, and your c value is 7. So plugging it into the quadratic formula, we have the opposite of b, so negative 4 plus or minus the square root of b squared, which gives you 16, minus 4 times 1 times 7, which gives you minus 28, all divided by 2 times a, which is 2. So when we simplify this, 16 minus 28 is negative 14. Well, right there we have to stop. You cannot take the root of a negative number. So therefore that means that there are no real roots. Okay? So this is a graph that does not cross the x-axis. And if we look back at this equation in vertex form, we have a vertex at negative 2, positive 3, and it's opening up. So we can see it's above the x-axis. It will not cross the x-axis because it's opening up and it's above. So final thing that we can note is that when we're looking at underneath the square root symbol, we have our what's called the discriminant, our b squared minus 4ac. And that can be used to determine the number of real roots that we'll have. So when b squared minus 4ac is greater than 0, we're taking the square root of a positive number. We'll have two real roots because we'll have plus or minus the square root. When b squared minus 4ac equals 0, we're taking the square root of 0. So we're not going to be adding or subtracting anything because we're just adding or subtracting 0. And when b squared minus 4ac is less than 0, we're trying to take the square root of a negative number, and that's not possible. So therefore there are no real roots. So that's what, remember, what we're taking the root of. So if it's positive, 0, or negative, we can or can't do it. And that's telling us how many answers are possible for when y equals 0, what our x values can be. Okay? So what I want you to now do is practice some problems. I want you to now complete, having watched this video, I want you to complete page 300, do problems 1 and 4 EOL. That will just practice some of your knowledge and understanding, and then in class we're going to work on questions 6, 7, and 13. Okay, so again, just do the letters A and C and work on problems 1 and 4 just to practice your basic knowledge of the quadratic formula.